Good morning, Professor Ferrari. I'm Crystal Condor, and today I will explain how distribution really works in the pharmaceutical industry, from the moment a product leaves the plant to the patient it serves. I will keep a macro view, but go deep on what makes this chain special: regulated orders, transport, licensed warehouses, careful material handling that requires highly trained people, and specific roles in charge of a train as critical for public health as this one. I will compare Peru and the United States to see similarities and differences in the practice. Let's start with the basics. What does this industry really provide? It's not just pills. Pharma delivers therapies that must arrive safe, potent, and on time. Orals, injectables, intravenous products, biologics that are medicines made from living cells or their components such as vaccines, modern insulins, and antibodies, oncology, drugs, and controlled substances. Here, the product is not only the box, it's the condition in which it arrives, the clinical strength it keeps, and the handling each molecule requires. That's why distribution in pharmaceutical industry is not a simple logistic task. It determines health outcomes. A mishandled drug loses effectiveness. A late or out of temperature shipment leaves a patient without treatment. Then why did I choose this industry? Because this is the chain where logistics becomes mission critical and also a test of operational discipline. It requires tight control of temperatures 2 to 8 Celsius, 15 to 25 Celsius, frozen or ultra cold types, lot and serial traceability, chain of custody to prevent diversion or counterfeits, quarantine protocols when in doubt, and highly trained staff for receiving, storage, and dispatch. Also, I want to explain this industry because every decision needs two lenses at once: the clinical lens, patient safety first, and the operational lens, time, cost, and compliance. Simply put, if you miss a detail here, you don't just lose money. You can compromise a treatment, but also a life. And how has the industry changed over time? It moved from a relatively simple channel, manufacturer to pharmacy, to a multi-tier network with national wholesalers, specialty distributors for complex therapies, validated cold chain, e-pharmacies, and hospital channels with their own rules. The pandemic speed up this change and exposed weaknesses, as for example single sources dependencies, fragile routes, poor visibility, and cold chain weaknesses. The answer was resilience and caution. Alternative routes, safety stocks for critical types of medicines, real-time temperature and GPS monitoring, and stronger recall processes. Today, the standard is clear: ship smaller volumes more often, use qualified packaging, follow to send first what expires first, and run control dashboards that alert issues before they become problems. In short, pharmaceutical distribution evolved from apparently moving boxes to managing therapies with precision, and that mix of clinical impacts and operational challenge is exactly why it deserves a deep look. So, who manufactures and who consumes? In the United States, we see large pharma leaders that don't just make existing medicines. They always try to innovate new modalities, as Pfizer Laboratories, Johnson & Johnson, Moderna, and Teva or Sandoz Laboratories that are more focused on generic medicines. In Peru, especially in Lima, production is led by local labs such as Medipharma and Pharmaindustria members, plus imports from multinationals. Many oncology and biologic products arrive through importation and specialty distributors. But beside these big players, there are small manufacturers or specialized importers with short portfolios, and compounding pharmacies that prepare personalized prescriptions. In the country, provincial clinics and independent pharmacies buy small and frequent quantities of medicines, so wholesalers adjust routes and use cross-docking for urgent orders. In the US, medical offices and home infusion providers work with specialty distributors that deliver exact kits and schedule visits by therapy. On the consumer side, it's not only the final patient. There are hospitals, clinics, retail chains, independent pharmacies, public programs, and home care. Each group asks for different delivery requirements, larger quantities, higher drug complexity, or more documentation depending on the product. Now, about commercial relationships, pharma uses both B2B and D2C. B2B is when a manufacturer or wholesaler sells to another business, hospital, clinic, wholesaler, or pharmacy chain. This is the dominant model because it requires licenses, cold chain, and controls. In Peru, a lab supplies a national wholesaler that then serves Inca Pharma or Mi Pharma and hospitals. In the US, Cardinal, Cencora, or McKesson supplies CVS and hospital networks. D2C is when the medicine goes direct to the patient from a channel controlled by the manufacturer or a digital pharmacy, usually after telemedicine and a valid prescription. In the US, services like Amazon Pharmacy deliver to homes with temperature tracking for certain products. In Peru, D2C appears through chain apps with delivery, prior validation of the prescription, and passive cold-packed solutions for the last mile. And now, a common question is presented. What is the distribution process in pharmaceutical? In short, we will break it down. The process is the coordinated flow of medicines under good distribution practices from the plant or the manufacturer's DC to pharmacies, hospitals, and patients, through authorized intermediaries, guaranteeing right conditions, right quantity, and right time at every step. Because we handle high-stakes products and strict standards, a small deviation can ruin the rest of the chain and end in a product that fails the patient, or even trigger legal actions if the patient is harmed by an ineffective or altered therapy. That's why, more than in other industries, quality and control are absolute. This channel is highly regulated. It works within defined temperature range, demands full traceability with lot, serial, and thermal evidence, maintains security against theft and counterfeits, and manage reverse logistics for expired, damaged, or recalled goods. It also faces frequent inspections, so every process keeps manuals and records up to date. Now, key features of this type of distribution. First, order processing. Before the pandemic, it was not very common to handle most medicines online, especially those that require a prescription. That changed a lot. Today, you can buy from online pharmacies if you upload a valid prescription and any other required info, depending on how sensitive the medicine can be. On the pharmaceutical side, order processing acts as safety filter to confirm who is allowed to buy. For example, only people with the right medical indication or authorized entities can purchase. The systems must validate licenses, drug type restrictions, expiry dates, and more. Full documentation is generated and recorded. If something doesn't match, the product cannot be delivered, and the distribution process will not be completed to the customer. As noted earlier, transportation must meet very high requirements. Drivers receive specific training and, depending on the country's law, needs a permit to carry sensitive substances. Vehicles are refrigerated when needed and use validated data loaders. When there are many products, they are packed in qualified boxes that keep the required temperature range. Trucks run with GPS and active sensors always. With a local example, Saxenda, that it's a medicine for resistance of insulin therapy, that it's also distributed by a well-known Lima wholesaler, must be kept between 2 and 8 Celsius, and if it goes out of the range, the whole lot, even if each pen is expensive, is discarded. Warehouses operate with strong prevention measures because products may stay longer there. Sites must run 24/7, buy licenses, and pass authority inspections. They have 2 to 8 Celsius cool rooms and 15 to 25 ambient zones, calibrated sensors, and backup powers to protect inventory. Inventory controls tracks lot, expiry, product codes, and certifications, and often in monitored vaults. Cold inventory is costly, so medicines that need cold change are usually more expensive, since planning and controls are stricter and require more collaboration and more specialized personnel. Handling is especially delicate. Even if a product is already made and packed, you still need qualified professionals to operate the final steps safely. Pharmacists, quality engineers, and trained operators work with standard procedures. Receiving includes physical and documentary checks of each lot and its appearance. Final packing happens in clean areas that meet all requirements. There is double check for specific categories, barcode scanning to identify products correctly and to avoid mix-ups with labels, directions, or safety information. If there is any doubt, the product goes to quarantine to investigate before continuing distribution or being destroyed. These are caution ways to protect and make strict safety in such essential materials. Customer service matters because good communication makes the process smoother and faster, providing high-quality service and preventing misunderstandings about how a medicine works. Here the institutional customers buys and dispenses, and the final customers who buys at pharmacies or hospitals is the patient. For both, the promise is the same: right drug, right condition, right time, with clear information that helps understanding at every step. Here are the steps before operating the process. First, set objectives. In pharma, the core goals are to meet fundamental and advanced standards for safety, protection, and product quality. SPAD, correct quantities, correct temperature, correct tracking, correct efficacy, and full legal compliance. These goals act as a template to set a high bar and to understand the consequences of poor distribution. Second, analyze trade-offs. Opening more warehouses brings products closer and reduces time, but increases fixed cost and risk of expiry. Operating with fewer warehouses lowers overhead but raises freight cost and time in transit. This extra sensitive for biologics, vaccines, antibodies, injectable insulins, which usually needs a strict cold change, and it's better to move smaller, more frequent shipments to protect shelf life. Third, design the network with clinical and logistic criteria. Choose locations near airports or hospital zones with validated cool rooms and backup power. Map routes that respect times and temperature windows. Decide between on-fleet or a specialized cold chain. Fourth, implement. Put the plan into action by coordinating order processing with license and restriction checks, building qualified packaging for each thermal range, the training staff with clear procedures, including mock recalls and temperature excursion drills. Fifth, monitor and adjust. Track what really matters: on-time delivery, temperature excursions, order accuracy, inventory turns, returns, and recall response times. Then adjust routes, packaging, stock levels, or carriers so the system keeps its clinical promise in every shipment. Once the network is running, really hits. Daily demand doesn't come organized like factory output. That's where discrepancies appear. Quantity discrepancy. This type means that lab produce in big lots for efficiency. Hospitals and pharmacies want small, frequent orders, as for example, 10 boxes today, 6 tomorrow, 12 next week. The usual fix is the wholesaler, who buys the big cake and cuts it into portions for thousands of clients. This is called break bulk. Each pharmacy receives what it needs without buying a full lot, keeps a cycle of stock for high runner items, and that's the minimum you always need because they always sell. And for emergencies, use cross-docking, that boxes from the lab will skip storage and go straight to the final route. A Peruvian example for this type of discrepancy is that a batch of antibiotics arrives at Química Suiza. For normal orders, the wholesaler cuts and sends small quantities to Inca Pharma, Mi Pharma, and several clinics. If a clinic needs a surgery supply tomorrow, they use cross-docking. The box enter and almost immediately exist on a direct route. The wholesaler keeps cycle stock for high-turn items, analgesics, or base antibiotics to avoid stockouts. An external example is that McKesson receives large lots of insulin. For CVS and Walgreens, they deliver small and frequent. If a snowstorm closes roads, they activate cross-docking in another hub to keep product moving and use store-level cycle stock based on each area's sales history. The other type of discrepancy is called assortment discrepancy. Hospitals and pharmacies need a bit of everything, as tablets, vials, but a single lab doesn't offer such a wide mix. Solution for this is that a standardized formulary, official list of brand doses form is presented to avoid duplicates and plan better. An aggregator distributor who pulls products for many labs into one mixed order, and service-based bundles, buy by clinical service, pediatrics, dermatology, oncology, so the order matches real-world use. An example is an oncology centers that work with a specialty distributor that aggregates molecules from multiple labs. Quickly, it receives clinical baskets with what protocols require. If a new antibody is added, the distributor integrates it and coordinates scheduled deliveries. In distribution, there is no one-size-fits-all channel. The need for agents, wholesalers, and retailers change with each medicine. These middlemen vary depending on risk, temperature, range, and destination. The wholesaler is a merchant who takes title and it's essential to turn big lots into small, frequent orders, aggregate assortment from many labs, maintain temperature control storage, and cover wide geographies with reliable deliveries. A Peruvian example is that a wholesaler, like, as we talk about, Química Suiza receives biologics, oncology, and oral meds from several labs, keeps 2 to 8 Celsius and 15 to 25 Celsius rooms, and supplies Inca Pharma, Mi Pharma, clinics, and hospitals. So, when is a special distributor better? Also merchants, but focused on complex therapies that require strict cold chain, clinical documentation, and coordination with care teams. In a clinic with therapy or endocrinology services, the wholesaler acts as a specialized aggregator and schedules short deliveries with evidence of products quality review by experts. Agents and facilitators handle the deal making and transfer between parts of the chain. They don't own the product but earn a commission for the transaction and for opening, obviously, doors. Types include brokers who manage tenders and contacts with hospitals or public programs, and import-export agents who obtain permits, clearances, and customs for biologics or other special care products. Facilitators make the channel flow. Banks finance inventory and cover risk. To keep a correct track matters because proper tracks and call hubs keep the process smooth. In short, when the process gets heavy on regulations, finance, or operations, these roles helps by offering practical solutions. Sometimes it's possible to go direct from manufacturer to a single large buyer when volume is high or there's a public health emergency. An example are vaccine campaigns where the lab delivers to the ministry or a large hospital networks that then distributes internally to sites in different districts. Another case is bulk purchases from hospital systems that tight times windows. These contacts often happen in urgent situations. So, when to combine them? A lab can sell direct to high complexity hospitals, use a wholesaler for pharmacies, and get agents for tenders, while retailers run delivery. An example is a lab to national wholesaler transition for wide coverage and in parallel direct agreements with reference hospitals. In the pharmaceutical industry, different middlemen are used according to the context, convenience, paperwork, a huge hospital, or a broad distribution. So mixing roles is common to keep the flow smooth. Based on who is involved and the channel length and complexity, there are 4 levels. Level 0 is direct from manufacturer to large buyer. The lab delivers direct to a big hospital or health authority. It's used for high volume, low distribution complexity, and speed. In Peru, this appears in vaccination campaigns. The pros of this is that they used fewer steps and there are less risk of errors, and cons is that the receiver must have ready storage and transport, including cold chain if needed. The level 1 is from manufacturer to large retail chain to patient. The lab sells to a large pharmacy chain and the chain dispenses to the public. US example is that a manufacturer supplies CVS or Walgreens, and a local example is that a manufacturer sells to a large chains with many stores. The benefit is that there is a strong coverage and in-store control, but the cons, if cold or controlled items are included, the change must meet strict rules. The level 2 is from manufacturer to wholesaler to retail or hospital to patient. The most common in Peru is this one, and widely used in the US also. The wholesaler buys large lots, break bulks, and aggregates assortment. In Peru, antibiotics go from the lab to Química Suiza, and then in small orders to pharmacies and clinics. The benefits of this type and this level is that it solves quantity of assortment and reaches remote areas, but it demands strong quality controls, temperature, and careful mix management. The level 3 and the most completed one is from manufacturer to wholesaler to a specialty agent and to retail, hospital, and finally to the patient. This adds a specialty layer between wholesaler and dispenser, used for products that need clinical coordination, extra documentation, or fine handling, like many biologics medications, for example, vaccines and certain injectables, and it can imply more precision and safety for sensitive therapies, but at the same time, more steps means more coordination and costs, so process quality improves. Generally, in Peru, level 2 dominates because strong wholesalers handle break bulk, national coverage, and the broad assortment hospitals and change demand. When therapy is very delicate, level 3 appears to ensure special handling. In mass campaigns or large organizations with special requests, you may see level 0. So briefly, by need, an oncology hospital requires short, scheduled deliveries, temperature evidence, qualified packaging, and often a specialty partner that builds baskets by fields. A retail chain prioritizes high churn and fast replenishment, more cross-docking, daily routes, and store-level cycle stocks. An independent pharmacy needs small, flexible orders. The wholesaler aggregates assortment and consolidates drops to lower cost per stop. The public sector buys in macro volume, demands strict documentation and delivery windows. The channel tends to be direct with one or two heavily intermediaries. D2C, chronic patients, needs reliable last-mile refill reminders and passive cold packs that holds temperature until the last part of distribution. Chain pharmacies are specialty stores. In Peru, Inca Pharma and Mi Pharma, the ones we already mentioned, mix the pharmaceutical part with beauty and basic services, with app and delivery. In the US, CVS and Walgreens include quick clinics, vaccinations, and adherence programs with strong digital support. There is scrambled merchandising. They add non-pharma categories like personal care or snacks. This boosts convenience and basket size, but they must protect the clinical focus and manage added operational complexity. Other formats can coexist. In the US, Walmart and Costco run pharmacies inside supercenters or clubs. In Peru, supermarkets host pharmacy modules via partners. Online retailing grows in both countries with prescription validation and last-mile call protocols. The wheel of retailing is a marketing model that explains how retailers evolve. Change often starts simple and low price, then grow by adding services and raising prices, then mature with costly structures. If they don't adapt, they become vulnerable to new, lighter, cheaper entrants. Stage 1. Focused on price and convenience. Small stores, essential assortments, little decors, simple processes. In pharmaceutical industry, that means emphasis on generics and OTC market. A neighborhood pharmacy in Peru that prioritizes generics is a clear example of this. Stage 2. Growth and trading up. Better experience, broader assortment, health services, in-store, delivery, loyalty, margins improve. Examples are vaccination drives, pharmacist tele-advice, app ordering with subscriptions, and this is what chains like Mi Pharma and Mi Pharma do currently. Stage 3. Maturity. A strong brand but higher cost. Many locations, specialized staff, in-store clinics and tech. Its prices are often higher than new entrants. In the US, CVS shows this with clinics, insurance, and ambulatory services under one roof. Stage 4 is when the business starts declining and having vulnerabilities. New competitors arrive with lower prices, simplicity, and lower fixed costs, like virtual pharmacists and subscription discounts. This is constantly pressuring the mature retailer to become learner. To close, difficulties in this change are really common, especially seen during the pandemic. Quality problems, poor emergency readiness, and shortages of essential products. A frequent issue is cold chain breaks or temperature excursions. Many drugs, especially biologics like vaccines, insulins, and antibodies, only work within strict temperature bands. A single excursion in transit or storage invalidates the lot if it fails standards, creating extra cost and leaving patients untreated. In Peru, this happens due to power outages or hard-to-reach areas with poor roads or severe weather. To overcome this, companies validate routes before operations, use qualified packaging with data, set backup carriers, and have backup power in warehouses and even in trucks. Real-time monitoring and refrigerated trucks with quarantine protocols for deviation are effective examples. Another issue is counterfeiting and the gray market. High-value drugs attract thieves and resell outside illegal channels. The risk is double: money lost and patient safety. Solutions include unit-level tracking, scanning every transfer, tamper evidence seals, surprise audits, and thwarted penalties. In Peru, formal distributors combine seals, documentation checks, and product certificates to authenticate and push low-quality fakes out of the market. So, in conclusion, pharmaceutical industry will always remain one of the most essential pillars of global health. Its complexity makes every link in the distribution chain a matter of life, not just logistics. As technology and science advance, this sector will continue evolving, but precision, transparency, and responsibility will never stop being fundamental. The future of this industry depends on how carefully every decision is made, from manufacturing to the patient's hands, because in this field, every step literally saves lives.